Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. So you can recall that in the last lecture we started a discussion on the use of ggplot2 package. And our objective is that we want to learn how to create different types of graphics and plots in this package. So in the last lecture, we had discussed or we had understood the basic fundamentals of the ggplot2 package, that what are the different aspects in which we have to give the data, and then we have to add different types of layers to create various types of graphics. And as I promised you that, that in this lecture, I will take an example, and once I try to use all the commands which were discussed in the last lecture, then you will see that creation of graphics in the ggplot2 function is very easy. Yeah, it is little bit different the way we used to do it on the R console using the graphics which are available inside the base package of R. So let us begin this lecture and try to take an example to understand these basic concepts. So you can recall that we had discussed in the last lecture that in this ggplot2 function, plot2 package, we have a function ggplot which initializes a ggplot object. And this can be used to declare the input data in the format of data frame and graphic to specify the set of plot aesthetics intended to be common throughout all subsequent layers unless specifically overridden. And then we are going to use it something like ggplot, then we have to give the data, mapping, environment, etc. But let us try to take a very simple example and try to plot graphic, and then I will go step by step, and in every step I will try to explain you some concept. So this is an old example that we have used in the earlier lecture, where we have obtained the marks of 20 students in an exam out of 500 marks. And this data is about the number of hours they study per week and the marks obtained. So we know that it is something like this. This data is like this. If a student is studying 23 hours in a week, then the student is getting 337 marks. If the student is studying 25 hours in a week, then the student is getting 316 marks, and so on. So this is a data. So what I try to do, I try to create here two data vectors, marks and hours, in which I try to store this data set, right? And based on that, I try to create here the data frame using the command data.frame using these two variables, marks and hours, like as this, hours comma marks. And I give it a name here as a df marks hours. df means data frame. Now in this step here, I am trying to add here one more column in this data frame, and I am trying to declare the result of these students based on the concept that if a student has scored more than 350 marks out of 500, then the student is declared as pass, and if they are less than 350 marks out of 500, then the student is declared as a, say here, fail, right? So I try to do here that I try to write down this data frame dollar and here result as a new variable which I am trying to create. So I will use here the conditional statement of if else. I believe that you people are aware about the R commands and how to use the if else statement. So if else statement is something like this. I will write down here IFELSE, and then my condition that df marks hours dollar marks. That means the data on the marks in the data frame df marks hours is greater than or equal to 350, then the student will be declared as say pass, else fail, right? So if you want to, yeah, I can just rewrite my condition that if a student has scored more than or greater than or equal to 350 marks out of 500, then the student is going to be declared as pass. So now you will see here the data frame which I constructed using this hours and marks using this command data.frame hours mark, it will look like this. This is the data on the hours and this is the data on the marks. And now when I try to add here one more variable df marks hours $result using the if else statement, then it will add a column to this data set. You can see here like this. Now the same data frame df marks hours will become like this, right? So you can see here that the student has received 337 marks, so the student is failed. And similarly, if a student has scored 374 marks, which is more than 350, so the student has been declared as a pass. Well, I am doing it because at a later stage I am going to use this aspect. But at the moment I will be using only the two columns on this hours and marks. So this is my data frame, which is created by using the command data.frame hours marks, and when I am trying to add here one more variable, this is how the data will look like. Right. Okay. So now I start preparing this graph. So we will use here the ggplot function to build a graph. And for that we have to specify the data frame which we are going to use, that we already have done. Now we have to specify the mapping of the variable to the visual properties of the graph using the aesthetic function AES. So AES function is going to be used to specify that how the graphs will look like. So if I try to understand this issue, this problem of creating the graphics, then let us start looking at the relationship between hours and marks, right? So in order to specify the data and the mapping, first we need to install the package ggplot2. So we use the command install.packages, and you can install it. I already have installed it on my computer. Then I will upload this package using the library ggplot2, right? And then I use here the command here, as I told you earlier, that ggplot data is equal to df marks hours. Now I need to specify what is to be plotted on the x and y axes. So for that, if you recall that in the last lecture we had given this command, mapping is equal to AES. AES is the function to give the aesthetics parameter to the graph. So if you try to recall that in the earlier lecture I had used this concept that if in the XYZ data frame there are two columns, X data and Y data, which have to be specified on the X and Y axis. So the same thing is happening here. I am writing that XYZ data frame as df marks hours, and then I am using X data as a hours to specify the data on the x-axis by writing x equal to hours, and similarly the data on the y-axis to be plotted is the marks. So I am writing here y is equal to marks, and I create this graph, and you can see here this graph comes. This is the screenshot, but you will see that this graph is empty. There are no points here, right? Why this is happening? Actually, we specified that hours will be mapped to x-axis, the data on hours, and the data on marks will be mapped to the y-axis. But we have not specified that what is to be placed on the graph, and that is why it is here blank. There is only a gray background. So in order to specify that whether the data has to be plotted using the points, lines or bar, etc., unless and until we do it, the graph will remain blank. So then we use here the option here geoms, G-E-O-M-S. They are the geometric objects like point, line, bars, etc., which are to be placed on the graph, and they are added using the function that starts with GEOM. In case if you recall that in the last lecture I had written it like GEOM underscore star. And after that, I had told you that we will write something in place of the star. So now we are going to write here point in place of star. So we start adding points using the command GEOM underscore point, POINT, this function for creating the scatter plot. And in this ggplot2 graphs, you will see that functions are chained together using the plus sign to build a final plot. How? This I will try to show you. If you try to see, this is the ggplot2 data is equal to df marks hours, mapping is equal to AES, x equal to hours and y equal to marks, that we had given earlier, and which has produced a blank graph. Now I am adding here plus GEOM underscore POINT. Right. So you can see here I am adding here a command using the plus sign, which I told you that we used plus sign, and then in the function GEOM underscore I am adding here point. So this will now add point to my graphic. So you can see here all these points have been placed here. And on the x-axis we have the hours, on the y-axis we have here marks, right. And after this, there are various options to control such parameter defined in the GEOM underscore point function. For example, the color, size, alpha. The color control the color of the points, size control the size of the points, and alpha control the transparency. So if there are points which are overlapping with each other, then this alpha function helps us in visualizing the overlapping points. And the interpretation of alpha is like this: if I choose alpha equal to 0, that means the points are going to be completely transparent, and if I use here alpha is equal to 1, that means the points are completely opaque, right. So for example, if I try to show you here, I try to add here this color alpha and size inside the geometric underscore point function within the parenthesis. So I use here color is equal to red, and I use here alpha is equal to 0.4, and I use here size is equal to 7. So you can see here this earlier graph which was obtained here like this, where all the points were in black color in the default size. Now the size of the point has actually changed. This is now here like this, bigger, which is controlled by the option here size. And you can see here the color of this point here is red. So you can see here this is the red. Now you can see here alpha is equal to here 0.4. So for example, if you try to see here at this point, there are 2 points which are overlapping here. So you can see here when the points are overlapping, then these points are reasonably transparent, and when they are trying to overlap each other, you can see what's happening. So this is how you can create these things. Now let me first try to show you these things on the R software, so that you become more comfortable, right. So first let me try to create here the first data frame of marks and R's. So you see this is here. So you can see here now this is my here data frame, which has only 2 columns. Now I try to add here the third column of result based on if a student has received more than, greater than or equal to 350 marks, then the student is declared pass, otherwise fail. So you can see here now in the same data frame, now one more column has been added. So now my data is here ready for use. So now let me try to upload here the package library ggplot2. I already have installed it, right. So now this data frame is prepared, right. Now after this, I try to use here this command, that ggplot2, and you will see that what is produced. You can see here now this graphic is produced, which is here completely blank, although you have specified here that on x-axis and y-axis the data on hours and marks respectively is going to be there, but there is no data on this graphic because you have not specified how those points should look like, right. So for that I use here the option here, that plus this gem underscore point. So in the last command you will see only I have just added here the command here, this gem underscore point, and all other commands remain the same, but you will see here as soon as I execute it, you get here this black data points. Now in case if you want to change it, right, as I shown you using the option of here color, alpha and size, right. So for example, if I say here this is here like this, you can see here this color has now become red and transparency level is also changed. And if you really want to change it, suppose if I say here this size here is suppose here 20. So you can see here that the size has increased, and you can see here because of this transparency level you can very clearly see what's really happening in the data. And if you try to change the color also here, suppose if I say here blue, so you can see here this is now here like this. And similarly, if you try to change here the transparency level here, so you can say here 1, this will become completely opaque, you cannot see anything. So you can see here these are the different aspects of the graphic which you can control very easily in the ggplot2 package. Now we come to some more aspects. Suppose in this graphic I want to add here a line. Why a line? If you try to see here, in this case it looks like as if the point is lying, the points are lying approximately on a straight line like this one, or here you can see a straight line is passing through somewhere here like this. Well, this line is obtained using the concept of principle of least squares, right. So but we want to know that what is the line of best fit. So a line of best fit can be added using the command GEOM underscore smooth. So once again you can see here the command which I explained you earlier, like a GEOM say star. Now you are writing smooth, SMOOTH in place of star, and these functions will have options like you can specify what type of line you want. Is it linear, quadratic or non-parametric? What should be the thickness of the line, what should be the color of the line, whether you want a confidence interval around the line or not. So those who are familiar with statistics, you know that there is a concept of confidence interval, and whenever we make such a line, there is a confidence interval associated with the coefficient. So if you want to plot them here, those options are available here. For example, if you want to say here, want to plot here a linear line, and so I have to add here the option here GEOM underscore say smooth, and within the parenthesis I have to give here the method is equal to LM within double quotes. LM means actually linear model, right. Towards the end of this course, we will also study the topic of principle of least square, and then there we will use this concept LM. So you can see there that all other commands, they remain the same as earlier, but now in this case you can see here that this blue color line is added to the graphic, and you can see here there is a light gray, some two lines are there under which there is a gray region. So this is indicating the confidence interval, right. So this is how you can modify your graphic over here, right. And after that, if you want to add here some more aspects over here, then that can also be added. For example, in the same aspect, we are trying to use here two more options, SE equal to false and size is equal to 2. And these two options are added under the GEOM underscore smooth function. And now you can see here at every point we are using here the plus sign. Whenever we want to use the geometric underscore point, we use plus sign. Then we wanted to add geometric underscore smooth, then again we are using a plus sign. So this is what we meant when I told you about this plus sign. So what is this going to do actually? The option of actually color is equal to result is used under this this aesthetic function. So this will actually map to an aesthetic aspect of this graph, right? And then we are using here S is equal to false. This is added under this geometric GEOM underscore smooth function to suppress the confidence intervals. If you make it true, then it will be there. For example, you can see here that in this graph, this confidence interval is there in the gray shade, right? And then let us try to see what happens, right? So if you try to now see here, the data has been classified and into two parts, fail and pass. Do you remember that in the beginning you had given or you have added a variable result based on if a student has scored more than or equal to greater or equal to 350 mark, then the student was declared as pass, and if less than 350, then the student was declared as fail. So now you can see here that in the AES function, that inside this AES function, you have added here the option color is equal to result. Earlier it was only x is equal to hours and y is equal to marks. Now you have added color is equal to result. So this data has been divided into two parts based on the data on the result. Result has two categories, pass or fail. If you have more categories, then also it will be taken care automatically. And then this is going to actually change the aesthetic of the graphic. How it has changed? Now you can see here it looks different than the graph which you had prepared here. Now all those students who have actually passed, they are here, and those who are failed, they are plotted here, and accordingly you have prepared here the lines using the command LM in both the cases. The color of those points where the students have failed, this is here red, and the color of the point where the student have passed, this is here actually blue, right? And then there are two different lines for fail and pass. So our sort of grouping of observation has been done, and based on that two different lines have been created. And since you have used here the option S is equal to false, so that is why there is no confidence interval here like this. If you make it here true, then possibly some confidence interval here will appear like this, right? So let me try to show you these things on the R console here. So firstly, let me just copy this command over here, and I will try to show you in a systematic way what I am trying to do. So you can see here, if you make it, you will get here this plot. Now under this plot, if you try to add here this option of geometric under smooth, so this is going to add here a line, and there is a confidence interval, and here you can see that white tilde x means it is indicating the command that is being used. Now after this, I try to use here this command, that under this geometric smooth method, I will try to add here SE equal to false and 2, and there I will try to use here this color is equal to result, right? So first let me try to I will just show you how I am doing it. So if I try to see here in the aesthetic function, you are trying to use here the command here, that what is this command? Color is equal to result, right? So if you COLOR is equal to, say here, result, this is happening here. So if you try to see what happens to this thing, if you try to add it here, you can see here that this that the data has been divided into two parts, say fail and pass, right? And it is based on the data which was given in the result, right? But now if you try to add it here, if you don't want here this confidence interval, so I try to add here C is equal to false and size is equal to 2. So if you try to add it here, I will say here SE is equal to false and size is equal to here, suppose here 3, suppose let me take it. You can see here now this has become like this, right. So you can see here that the graphic has become very clear in explaining what exactly do you want here, right. So now I want to give you here some more aspect that how are we going to control the aesthetic, in the sense that we want to customize our this plot by giving it labels for axes and legends, and we can give here a custom title, subtitle, caption, etc. So this can be done using the function here labs. So you can see here all these commands is from the earlier. Now I am using here the option here plus and then here labs, LABS. Then inside the parenthesis of labs function LABS, I am trying to give here title is equal to within double quotes relationship between marks and numbers of hours of study. Then I am trying to give here subtitle, something like within double quotes class 10 result. Then I am trying to give here the caption. Caption is something like within double quotes government college. On the X is equal to say time in hours. Y I am giving here marks out of 500, and color is equal to here based on result question mark. This is the pattern I try to give you this option. Now if you try to compare it with your earlier type of plot, for example, when you try to use the command here main, then main was earlier used to give the title, but now here this title title is used to give the title. So these are the minor differences when you are trying to use different packages, but if you try to execute it here, you will see here everything is coming here. The title is coming here, relationship between marks and number of hours of study. Then subtitle class 10 result, on x-axis time in hours, on y-axis marks out of 500, and this is the data for government college. So you can see here all these things are possible here to improve the aesthetic or the look of this graphic, and then which will give you much better idea. And then after that I will try to show you that this appearance can be further modified by using the option here themes. This theme function starts with the like THEME underscore something we have to give. So this can actually control the background color, font, grid line, and legend placements, other non-data related feature of the graph. And we want to have here a cleaner theme. So what we use here, that in the earlier command I simply use here one command here plus theme underscore minimal, right. So this will give you here a graphic where you can see that the graphic is the same, but the background of this graphic is now white. Earlier if you try to see, this was actually here gray. So now you can choose different options and then you can improve the graphics over here. So now let me try to show you these options in the R software. So I will simply try to use only this part here in my R. So you can see here we already had used this one, and then now I am trying to copy and paste this thing, and you can see here that all this title etc they have been come, right. And now at the end you simply try to add here one more this aspect of theme underscore minimal, and you can see here this is coming out to be here like this. Now you can see here that this background has become actually here white. Earlier if you try to see, it was actually gray. Now by using here this here theme, it is becoming here white, right. So now you can see here that I have taken an example to plot only a scatter plot in this lecture, and the same thing can be used in the R package also, using here plot. Just plot and within parenthesis you give the data, right. But in ggplot also we have, but my objective here was not to give you the details about the plot function, which we will take later on. But my objective was that how are we going to create a graphic inside the ggplot2 package. So for that, what I have done, I started with a very small data set, and then I created a basic plot, and then I added different type of options. And my objective was I wanted to give you this concept like how to use the plus sign, how to use the something like geometric or say GEOM underscore option, theme option, etc. And my objective was to show you that by adding this different aspects, you can change the graphics. You can change the look of the graphics. You can control the information which you want to present on the graphic in the way you want. So my objective was only to explain you with an example that how the plots are created in the ggplot2 package. In the next lecture, I will now take up some known graphic which you already have learned, and I will try to show you that how the same graphic can be created in a ggplot2 package using these types of command. But now you have a fair idea that how these different aspects which we discussed in the last lecture, they are used here. So my request to you will be, at least please try to repeat this example yourself, and then try to watch the last lecture also, try to listen it and try to see, can you now correlate it with the different aspects? I can promise you it won't be difficult. And now you will be ready to understand and to plot various types of graphics using the ggplot2 package. And now you can also understand that why I have taken this topic, because you can see the way the graphics are created in ggplot2 package. It is a little bit different than what we used to do earlier. So I would request you, please try to take a small data set only, no big data set today, and try to repeat these things, these aspects, whatever we have discussed it over it, and see, are you going to get the same thing? Besides those things, if you look into the help menu of this ggplot function, you will see there are many options. And please try to execute them, try to experiment with them, and try to see how the graphic is going to look different by using different aspects. Once you know all these things, then you will be in a better position to take a call when you have to make a proper graphic for a given set of data, that what are the different options that can be used to make the graphic most informative and very aesthetic, that means good looking. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.